Hello everyone, my name is Leonardo Sousa. I am assistant professor at Carnegie Mellon University, and today I will present this study which was conducted with this group of researchers as you can see in the first slide. And this study generated a paper characterizing and identifying composite refactorings, concept, heuristics, and patterns. Refactoring consists of a problem transformation used to improve the structural quality of the software system. For example, removing code smells. A code smell is a suboptimal decision at implementation level. For example, when a class is too long and implements too many functionalities, or when you have a duplicated code, all of those are examples of code smells. In the literature, we can find several studies that investigate the characteristics and the impact of refactoring on removing or adding new code smells. However, this study tends to analyze each refactoring as a single operation. However, this is not exactly true in practice. In fact, there is a study that shows that from 40 to 6% of the times, developers apply more than one interrelated refactoring, which we call a composite refactoring. And there are several studies that investigate composite refactoring. However, each one of these studies has a different perspective on how to group refactorings to create composites. And depending on the perspective that the study decided to follow, maybe introduce some issues, some problems, in a such way that can compromise the findings of that study. And this finding may not yield a comprehensive understanding about the effects of composite on the incidence of smells. For example, let's consider this image. Here we have a system that has 3 commits. In the first commit, we have a smell called God class, which was removed due to refactoring in the second commit. In the third commit, we have another smell which was introduced. So this one was removed in green and this one was introduced. And we have 7 refactorings. And suppose a researcher wants to look this example and decide if this composite either introduce or remove smells in the situation. What is more likely to happen here? And this really depends on how the researcher decides to group these refactorings. For example, let's consider the work of Bibbiano and colleagues. Bibbiano investigated how to group refactorings as a composite. The definition of composite is a set of refactoring that are applied to a single code element. So they use as a constraint, as a criterion, one code element. So in this scenario, Bibbiano would have used 2 code elements, user controller and media controller. Consequently, they would have created 2 composites. The first composite related to the user controller and the second composite related to the media controller. So if you will look to this composite and these 2 elements, the conclusion would be composite have a positive effect on the quality of the system because this composite removed the God class. But in this example, that is not exactly true because even though this composite removed the God class, there is another code smell that was introduced. So in fact, these composites here, they do not have a positive effect. In fact, they have a neutral effect. But in Bibbiano's work, they have this conclusion about a positive effect because they do not consider the scope of the abstract controller. They only consider these 2 elements. So it really depends on the perspective that the researcher decided to follow. Depending on the perspective, they have one conclusion. For example, in the case of Bibbiano. So different conclusions can be the result of different perspectives. And then we start to wondering, okay, so we have different perspectives on how to investigate composite. So how can we explore that? How can we investigate the impact of refactoring on smell from different perspectives, not only using the perspective provided by Bibbiano, but also the perspective provided by other researchers? So to answer this big question, we divided our study to answer 3 research questions. I'm going to show here only 2 questions, but I invite you to go to the paper and take a look in the first research question. A second research question intends to investigate if composite tend to introduce more or remove more smells. So this is our second research question. And then we want to verify if there is any patterns that can say if there is a relation between some type of composite and some type of smells. To be able to answer these questions, we have to collect different categories of composites. Remember, a category of composite indicates a perspective that you are investigating that composite. And then as soon as we have different perspectives, different categories, we can mine the commit history of different software systems and investigate if the composites tend to introduce or remove more smells. So the first step here in our study was to identify different categories of composites. For this purpose, we proposed 2 heuristics. The first heuristic to identify composite is the commit-based heuristic. Basically, in this heuristic, we group together all the refactorings that occur within a commit. So all the refactorings that occur within a commit, we group them together as a composite. But there are some refactoring that cross-cut multiple commits. So in this case, we create another heuristic called the range-based heuristic. And the criteria to group refactorings here in this heuristic is to group all the refactoring that are affecting elements that are structurally related to each other in the system. For example, here, in our example, if we apply the commit-based heuristic, we would have come out with 2 composites. The first one related to the first commit, and the second composite related to the third commit. But if we apply the range-based heuristic, we're going to have only a single composite. It's the composite with all the refactorings. So we group all those refactoring as a single composite because all those refactoring affect elements that are structurally related to each other. So in this way, each composite has a different scope. This one has the scope of a commit, affecting all the elements in the commit. In the second heuristic, identifying composites that find the scope of all the elements that are structurally related to each other. So for our study, we have proposed these 2 heuristics, and also we applied the heuristic of Bibbiano, the one that considers the elements as a criterion. So for this study, we considered 3 heuristics. And these heuristics, we use them to collect the data. First, we mined the commit history of 48 software projects, collecting 14 types of refactorings and 19 types of code smells. After that, collecting these smells and refactoring, we have a total of 104,000 single refactorings, and we also conduct a manual validation with a subset of these refactorings. After that, we apply the 3 heuristics to collect the composites in our data set. And finally, we classify each composite based on its effect on the code smell. So if the composite removes smell, we say that composite is a positive. If the composite introduces a smell, we say that the composite was negative. If the composite neither introduce or remove smell, we say the composite was neutral. So this was the classification that we did. And this was the result for this classification after collecting the entire data. This was the result that we used to answer our second research question. As you can see here, the majority number of composites are neutral. But when you consider the positive and the negative composite, we start to see a little bit difference between the heuristics. So remember, each heuristic is a perspective to how to group refactorings. So if you consider the element-based heuristic, we have the result that we have much more positive composites than negative composite. But if you consider the commit-based and the range-based, the history is different. We have much more negative composite than positive composite. So again, the perspective that the researcher decided to follow really can tell really can change the conclusion for the developer. Really can change the conclusion of the study. And we have several findings. And one of these findings is, if a researcher wants to investigate composite and its effect on code smell, they should use the commit-based and the range-based heuristic, because those heuristics are the ones that have a broader scope, and they can be more appropriate to investigate how composites affect the incidence of smells. We have several findings related with this conclusion, and I invite you to go to the paper again and take a look on these findings. But not only that, as part of our third research question, we trying to see if there is any patterns that can say if there is a relation between composites and smells. And we are able to find 111 composite smell patterns. So these patterns are either removal or creational. So we find 84 patterns that can remove code smells and 27 that can create new smells. And in this slide here, I'm gonna present the patterns for two smells. The first one is the feature envy. Those are all the patterns that we find for the feature envy. So here in red, we have the patterns that introduce the feature envy, and in green, we have the patterns that remove the feature envy. So when we have several move attributes followed by a structured method, in 6% of the time, this pattern introduces a feature envy. On the other hand, when you have a structured method followed by several move attributes, in 96% of the time, this pattern removes the feature envy. So this pattern is very useful, for example, to create recommender system, because now we have exactly which sequence of effect can either introduce a smell or remove a smell. And we have several findings related with these patterns. For example, we found that developers tend to introduce smells like the feature envy when they do incomplete composite. When they start a composite like this one, and instead of applying another refactoring, they stop here and don't do anything else. This is an incomplete refactoring that leads to the introduction of feature envy. We also have patterns for God class. So we have much more removal patterns than patterns that create the God class. But this one is a little bit interesting. We found that the rename method and the extract method introduce God class. And this was a little bit interesting. How is possible to rename method to introduce God class? And we did a further analysis, and we find that developers tend to decrease the code cohesion when they apply these two refactors in conjunction with other changes. For example, when the developer extracted method and then they add new code to this method, they have to rename that method. So in this way, now the new name of the method match with whatever that method is doing. So in this case, when you have this happening in the code, this leads to the introduction of a God class. But notice here, the God class was not introduced because of the refactoring, but because of this new code that was introduced. Even though this pattern here was useful to indicate that this scenario leads to a God class. So our patterns can be useful to improve recommended systems in this sense. And this result was only possible because we analyzed different perspectives of how to group refactorings together using our heuristics. And the main contribution of our study was we propose a conceptual framework that can help other researchers to propose their own heuristics. We propose two heuristics to identifying composites. We also have different findings that can improve recommendation system, and also we providing a data set that other researchers can explore. So in summary, composite refactoring should be something that researchers should be investigating. And when they investigate, they should use different heuristics, because each heuristic can provide a different perspective on how a composite can affect the incidence of code smells. So if you want to know more about how to about the findings of this study, I invite you to go to the paper and take a look in our results. Thank you very much for watching this video, and I hope you can go and read our paper.